This is a key to topic 4, parts A and B. And on this worksheet, you're dealing with complex numbers. And so in part 1, you are asked to either add, subtract, or multiply complex numbers. And in part B, or the second part, you are asked to divide complex numbers. So let's take a look at the key to this. So we're going to start with number 1. So number 1, you're adding these two complex numbers. And so basically you're going to add the real number parts, and then you're going to add the imaginary parts. And so if you look at number 1, you have this real part, 7, and then 2. And so when you add 7 and 2, you get 9. And then if you look at the imaginary part of this complex number, you have a negative 5i and you have a positive 3i, and so those are like terms. And so when you combine those, a negative 5 and a positive 3 is a negative 2, and so you get 9 minus 2i. And remember, the directions did say to write in the form a plus bi. And so that's the answer for number 1. Okay, number 2, we had this for number 2. So you had the complex number 8 plus 7i, and then you're subtracting the complex number negative 3 plus 6i. And so if you look at this, you are subtracting. And so the first thing you want to do is either multiply through by negative 1, or you can take the opposite. So remember, subtraction means the same thing as adding the opposite. And so when you rewrite this, I could rewrite this part without parentheses because that's a 1 here, and 1 times 8 plus 7i is still 8 plus 7i. And then over here, if I distribute the negative sign through here, the opposite of a negative 3 is a positive 3, and the opposite of a positive 6i is a negative 6i. And then I just combine like terms. So 8 plus 3 is 11, and then a positive 7i and a negative 6i is just I. So I get the answer 11 plus I, and that's the form a plus bi. All right, so that is number 2. And number 3, we have this for number 3. This time we're multiplying the complex number 4i by the complex number 5i minus 2. And so we're going to use a distributive property, and it's a good idea to actually write out to write out that first step. So we have 4i times 5i, okay? And then over here I'm subtracting 4i times 2. All right, now you didn't have to write the step out, but here's what you had to write. You had to say, well, 4 times 5 is 20, I times I is I squared, all right? And then we have minus, and then 4 times 2 is 8, and 8 times I is 8i. Now, you got to remember that I squared is equal to negative 1. And so you have to replace this I squared with negative 1. And so I get 20 times a negative 1 minus 8i. And so 20 times a negative 1 is a negative 20 minus 8i. And then remember, you got to put this in standard form, which it is. So negative 20 minus 8i. And so that's the answer there. So that's answer number 3. So remember, you got to remember that I squared is equal to negative 1. Okay, number 4. We have this for number 4. We have 3 minus 5i times 2 plus 3i. And so notice you have these two binomials. So you can treat this like you would multiply two binomials. So you're going to say, remember FOIL, F-O-I-L. So first times first, so that's 6. 3 times 2 is 6. The outer is 3 times 3i is 9i. The inner, a negative 5i times 2 is a negative 10i. And then the last. So always be careful with the last when you're multiplying two binomials, the two complex numbers, I should say. So a negative 5i times a positive 3i. So remember, it's a negative 5i times a positive 3i. That's what you're looking at. Well, negative 5 times 3 is a negative 15, and then I times I is I squared. All right, so write it out like this. And then now what you want to do is combine like terms. And I can combine these two terms here. And also remember that you want to rewrite I squared as negative 1. And so now we get 6. A positive 9i and a negative 10i is a negative I. And then I have minus 15 times a negative 1, because I squared is equal to negative 1. Okay, now let's go ahead and simplify this. So I get 6 minus I. A negative 15 times a negative 1 is a positive 15. And then all I do is just add the 6 and the 15 together. And so when I add 6 and 15 together, I get 21 minus I. And so that's the answer to number 4. Okay, let's look at number 5. So number 5, we have this for number 5. We have, again, we're multiplying two complex numbers, 7 plus 2i times 7 minus 2i. And then I want you to notice, if you remember when you multiplied in the previous course, when you multiplied two binomials, and the first terms were the same and the last terms are the same except for the signs. Remember what happened to the outer and inner? Okay, so we're going to look at that. So again, we're going to use the fall method. So 7 times 7 is 49. The outer, 7 times a negative 2i is a negative 14i. And then the inner, 2i times 7 is a positive 14i. And then the last, so remember we have a positive 2i times a negative 2i. So that's going to be a negative 4. And then I times I is I squared. So remember we had this. We had 2i times a negative 2i. And so we get a positive times a negative is a negative. So that's what you see here. 2 times 2 is 4. And then I times I is I squared. Okay, now one thing you got to remember these are the 7 plus 2i and the 7 minus 2i are conjugates. So remember we talked about the idea of conjugates. Well, when you multiply conjugates, the outer and the inner cancel out. So remember, a negative 14i plus 14i is 0. So remember, those are conjugates. So the conjugate of 7 plus 2i is 7 minus 2i. And whenever you multiply conjugates, the outer and the inner cancel out. And basically what you're going to have left is just a real number. So when you multiply conjugates, remember, you get a real number. You're going to get a real number. Okay, so I have 49 minus 4. And remember, I squared is a negative 1, so you got to put negative 1 here. And so now I get 49 plus 4, because a negative 4 times a negative 1 is a positive 4. And so we get the answer 53. So remember, that's a real number. So 53 is a real number. Okay, number 6. So number 6, we have this. So again, we're multiplying two complex numbers together. All right, and so you're going to use the fall method again. Okay, so I get 3 times 2 is 6. The outer, 3 times 4i is 12i. The inner, a positive I times 2 is a positive 2i. And then the last, a positive I times a positive 4i is a positive 4i squared. Okay, so now let's go ahead and combine like terms and keep in mind that I squared is equal to negative 1. So we get 6. 12i plus 2i is 14i. Plus, and then 4 times negative 1, because remember, I squared is equal to negative 1. So I get 6 plus 14i, a positive 4 times a negative 1 is a negative 4. And then combining 6 and negative 4 together, I'm going to get 2 plus 14i. So that's it. That's the answer number 6. And then in number 7, we have 5 minus 3i squared. Now remember, when you're squaring a binomial, remember that's the same thing as saying that binomial times itself, or that factor times itself. So when you square a factor, you can rewrite it as in this case, 5 minus 3i times 5 minus 3i. And so we're going to use the fall method. 5 times 5 is 25. The outer, 5 times a negative 3i is a negative 15i. The inner, now remember, when you square a binomial, the outer and the inner are always the same. So negative 3i times 5 is still a negative 15i. All right, now be careful with this one, the last. So remember, a negative times a negative is a positive. 3 times 3 is 9. I times I is I squared. Okay? All right, so combining like terms, I get 25. A negative 15i and a negative 15i is a negative 30i plus 9. And remember, I squared is equal to negative 1. So 9 times I squared means 9 times negative 1. So now we get 25 minus 30i minus 9. And then combining like terms, the 25 subtract 9, I'm going to get 16 minus 30i. So that's the answer to number 7. Okay, now let's look at number 8. So part 2, you got to remember, always read the directions. So in part 2, it does say make sure you show the work. So you have to show the work, and also keep in mind in the directions you had to put this in standard form. All right, so just make sure it's in standard form. All right, see right here, standard form. All right, so let's look at number 8. So number 8, we have this. We have 7 divided by 3 plus 2i. So that's our problem. Now remember, we want to, when dividing complex numbers, you want to make sure that your denominator no longer has the I in the denominator. So that's where you're going to multiply both numerator and denominator by the conjugate of the denominator. So basically what we're going to have now is this. So you're going to say, well, if I want to get rid of this I that's in the denominator, then I'm going to multiply both numerator and denominator by the conjugate of 3 plus 2i. Well, the conjugate of 3 plus 2i is 3 minus 2i. All right, and again, what you do to the numerator, you have to do to the denominator. And so now I get this. I get 7 times, I'm going to put this as one fraction now, 7 times 3 minus 2i divided by, and then I'm just going to go ahead and rewrite this. I get 3 plus 2i times 3 minus 2i. Okay? All right, now let's look at the numerator. So now we got to get rid of the parentheses. So I'm going to, in the numerator, I'm just going to use the distributive property in the numerator. So I get 21 minus 14i. All right, now in the denominator, get rid of those parentheses, you have to use the FOIL method. But remember, those are conjugates. So always remember that if those are conjugates, the denominator should now just be a real number. And it will be, so watch, 3 times 3 is 9. The outer is a negative 6i. 3 times negative 2i is a negative 6i. The inner, 2i times 3 is a positive 6i. And then the last, so you got to always be careful with the last. A positive 2i times a negative 2i is a negative 4i squared. Now remember, when you multiply conjugates, the outer and the inner are going to be opposite, so those cancel out. And so now what I have is this. I have 21 minus 14i divided by 9 minus, and then 4 times a negative 1, because remember, I squared is equal to a negative 1. So I squared is equal to negative 1. So I get 21 minus 14i divided by 9. A negative 4 times a negative 1 is a positive 4. And so I get 21 minus 14i divided by, and then 9 plus 4 is 13. Now remember, the directions said write it in standard form. So to write a complex number in standard form, see this how it looks? You're going to say 21 divided by 13 minus 14 13ths I. So that's the answer you need to write. All right, and for the most part, this is the work. Okay, so that was number 7. I'm sorry, number 8. Let's look at number 9. So number 9, we have 8i divided by 2 minus 3i. So 8i divided by 2 minus 3i. And so again, you're going to get this I out of the denominator to make this a real number in the denominator. You're going to multiply the numerator and the denominator by the conjugate of the denominator. So the conjugate of the denominator is 2 plus 3i. What you do to the numerator, you do to the denominator. And now we're going to rewrite this just like we did number 8. So you're going to say 8i times 2 plus 3i divided by, and then 2 minus 3i times 2 plus 3i. Okay, so let's get rid of the parentheses in both numerator and denominator. So in the numerator, I'm going to get 8i times 2 is 16i plus, and then 8i times 3i is 24i squared, because I times I is I squared. So you always got to be careful. Okay, let's look at the denominator now. The denominator, though, if you look at these two complex numbers, those are conjugates. And so remember, when you multiply conjugates, you're going to end up with a real number in the denominator. So in this case, number 7, remember number 8, that was 13. Same thing going to apply here. So I get 2 times 2 is 4. The outer, 2 times 3i is 6i. The inner, negative 3 times 2 is a negative 6i. And you see those are opposites, so those are going to cancel out. And then a negative 3i times a positive 3i is a negative 9i squared. And so now I'm going to get 16i plus 24. Now let's go ahead and rewrite I squared as negative 1 divided by, and then 4 minus 9, and then I squared, remember, is a negative 1. Okay? And so now I get 16i, a positive 24 times a negative 1 is a negative 24, divided by 4. A negative 9 times a negative 1 is a positive 9. And then let's go ahead and rewrite this better. So I'm going to put the numerator, remember you want to write the answer in standard form, so let's put the numerator in standard form. So I'm going to get a negative 24 plus 16i divided by, and then 9 plus 4 is 13. And then let's go ahead and rewrite this in standard form. So I get negative 24 thirteenths plus 16 thirteenths I. And so that's the answer to number 9. Okay, and then finally number 10. So let's look at number 10. In number 10, we have 3 minus 4i divided by 2 plus 3i. And so again, I want this denominator to be a real number. So right now it's a complex number, so I don't want that I in the denominator. I want this to be a real number. And so you're going to multiply both numerator and denominator by the conjugate of the denominator. The conjugate of the denominator, 2 plus 3i, is 2 minus 3i. And what you do to the numerator, you do to the denominator. And now notice in the numerator you have two binomials, and in the denominator you just have the same thing. So let's go ahead and put those in parentheses. So it'll be 3 minus 4i times 2 minus 3i divided by 2 plus 3i times 2 minus 3i. All right, and now we're going to use the fall method on both. So let's look at the numerator first. So 3 times 2 is 6. The outer, 3 times a negative 3i is a negative 9i. The inner, a negative 4i times 2 is a negative 8i. And now again, always be careful of the last. A negative 4i times a negative 3i. So a negative times a negative is a positive. 4 times 3 is 12. I times I is I squared. So remember what you had was this, 4i times 3i. So 4 times 3 is 12. I times I is I squared. So that's what you see here. Okay? And then the denominator, those are conjugates, right? So the I and the inner is going to cancel out, and you're going to end up with a real number in the denominator. So I get 2 times 2 is 4. The outer is a negative 6i. 2 times a negative 3i is a negative 6i. The inner, positive 3i times 2 is a positive 6i, and hence they cancel out. And so I get 3i times a negative 3i is a negative 9i squared. And so let's go ahead and simplify what we can in the numerator. So in the numerator, I have 6, a negative 9i, and a negative 8i is a negative 17i. Plus 12 I squared, remember, is a negative 1, divided by, and then 4 minus 9 times a negative 1. And so we get 6 minus 17i, 12 times a negative 1 is a negative 12, divided by 4, a negative 9 times a negative 1 is a positive 9. And then, so 6 and a negative 12 is a negative 6. I get negative 6 minus 17i, divided by 13. And then writing that in standard form, I get negative 6/13 minus 17/13 I. And so that is the answer to number 10. So that is the key to this worksheet, topic 4, parts A and